Hello, today, in continuation of the topic of quantum numbers, we will explain how the filling of electrons in an atom is constructed. To do this, recall that there is the Aufbau principle, which allows us to determine which levels and which sub-levels will be filled in a certain order. Why does this apply to quantum numbers? Because the filling of energy levels and sub-levels is constructed exactly using quantum numbers. Besides, we will find out today how other principles which concern to quantum numbers work. So, let's start with the Aufbau principle. The fact is that the electrons in an atom are filled in a certain order. The first level is filled first, the S sub-level. Let me remind you, the number 1, which is written here, is nothing but the principal quantum number. And S is the letter designation that corresponds to the orbital quantum number. So we're writing down 2 numbers in this entry. So this level is inferior in terms of the energy number. 2 S's. Then 2 P's. After 2 P's comes 3 S's, followed by 3 P's. But after 3 P's, according to the Aufbau principle, it's 4 S's, followed by 3 D's, then 4 P's. The next one goes 5 S, then 4 D's, followed by 5 P's. Next goes 6 S's, 4 F's, then it's 5 D's, 6 P. The next one goes 7 S, 5 F, followed by a 6 D, and 7 P. What I have written down is actually a summary of the periodic system from the 1st to the 7th period. But the question arises, why does the filling go this way? Well, for example, why do the 4 S's go before the 3 D's, and so on? You can see in this sequence, perhaps to you, a seeming incorrectness. In fact, there is no error here. The point is that the filling of levels and sub-levels happens strictly according to quantum numbers. So let's explain how it looks like. So if we denote N, and here L, and here the sum of these numbers N plus L, then we have the following pattern. Let's do the math, shall we? 1s. Then the principal quantum number is 1. The orbital number for the s electrons is 0. So the sum in this case will be 1. So next, second level S, so I'm going by this principle. Then the principal number is 2, the orbital number is 0, and here the sum will be 2. As you can see, there is an increase. So the level and the sub-level that has the smallest sum, N plus L, should be in front. Next, 2P. Then the next one will be 2 here. There will be 1 and 3. 3s. 3 here would be 0 and equal to 3. Now let's see, formally they have these sums equal to the same value of 3. Why then 2p comes before 3s? The point is that the main quantum number is in general not accidentally named as the main number, because the number which is the smallest, and the smallest is in this case here, then this value should go before, precisely because the main number is the smallest. The next one, 3p, that would be 3, there's 1 here, the sum is 4. 4s, 4, orbital 0, sum of 4. Again the same pattern. Notice the sum is the same value 4, but here it's a smaller value. Next comes 3, D. So in this case we get 3. For d electrons, the orbital number is 2. 5, so that's why 3 Ds comes after the 4 S's. And next comes 4p. Here we get 4 orbital 1. The sum is 5. And then why does 3 Ds come before 3 S's? Because this number in this case is the smallest number. Therefore, there is no contradiction in this case. The series is constructed absolutely correctly, and as you can see, it is in exact accordance with the quantum numbers. In this case, with the principal and orbital quantum number. So there are no errors here. Now, let's find out how the electrons are filled in by quantum cells when we show them as arrows the electrons in these quantum cells. So, let's explain how the Pauli principle works. This principle was accordingly worked out to explain how the electrons in the cell should be properly distributed. So according to Pauli's principle, it follows that all quantum numbers, let's remember they come in an L, ml. And ms, the electrons in an atom can't all be the same. Thus, they must be distributed in the quantum cell strictly like this. For example, one cell up and the second cell down. How? They cannot be distributed, that is, it will be allowed in this case. This situation is correct. Further, and as it would be wrong, that is, you cannot, and this is called the Pauli prohibition, then you cannot place the two electrons both upward by spin number motion, nor can you place the electrons both downward. It will be forbidden in this case. It turns out that such a motion will be accordingly wrong, that is forbidden, that is why it is called Pauli's prohibition. Consequently, the distribution of electrons must be strictly according to the Pauli principle. And if we were to place the electrons like this, then in this way the whole sum of these numbers would be exactly the same. But that's wrong. And plus this, I draw your attention to this, that the spin moment, if we were to calculate in this case both electrons, it would be equal in this connection plus 1 second. That's not allowed. Neither is the reverse allowed. When we have both of these electrons here have minus 1 second, that's not allowed either. So when we distribute the electrons in an atom, we necessarily follow the Pauli principle, which forbids doing it this way, but allows it this way. Now there is also Gun's rule. This rule deals with the point that has to do with the distribution of electrons over quantum cells. For example, we have 3p electrons. Let's say for elements that have this particular configuration at the outer level. 3, for example, p3, 4, p3. So how can we place these electrons? Well, we could do it like this, for example. By distributing all the arrows, for example, upwards. Next, we could do it maybe like this. By distributing all the arrows downwards. Then perhaps, let's say it's a combination like this. Perhaps you feel like that would be the right way to do it as well, and so on and so forth. There are variations of such electron distribution, but let us find out which ones are correct. How do we do that? Well, by Gun's rule, we have to take into account that the total spin moment, which in this connection must necessarily be maximal. This total spin moment, let's calculate, let's see how much will be the sum in this case of the spin numbers in this configuration, plus 1 second, plus 1 second, plus 1 second, plus 1 second here, plus 3 seconds. In this case, the MC would be minus 1 second, minus 1 second, minus 1 second, minus 3 seconds. As we can see, this value is inferior to the maximum value. So in this case, it is wrong, it would be prohibited. Now further, as it would be here, then we would say plus 1 second, minus 1 second, 0 across the cell. And in this connection, it would be plus 1 second. So this placement would also be incorrect, prohibited. And I also call your attention to the fact that when you distribute the electrons in the cells, it is for this reason that the first arrow must be strictly upward, because the spin momentum of the upward arrow would be plus 1 second. It is this value that is the maximum value in this case, and the downward first arrow cannot be, because the spin number would be minus 1 second, which is the smallest value. Hence, it is forbidden. Thus, when we write down the electrons in an atom, we stick to just the quantum numbers. And again, when we write down the electron form, we use two numbers. It's principal and orbital. When we talk about how electrons are distributed in cells, we use the other quantum numbers. Well, in Legund's law, we talk about how the spin number works. This is how we can see how our wonderful quantum cells work to describe the electrons in an atom. I hope that's clear. Goodbye.